Yeah. Can everybody hear me? Yes, in the back? Yes, thumbs up. Okay, great. Thank you all so much for coming today. We're all here, so we're going to go ahead and kick things off. My name is Maeve. I'm a reporter at Latitude Media. We're a news and events company focused on the energy transition, so I write for our news site. We also make several podcasts focused on energy. And I am really excited to be here today to chat about AI weather forecasting. And when we actually launched Latitude Media about 2 years ago today, one of the first articles that was written for our site was about how AI weather predictions could impact the grid. And we described late 2023 as the early days of AI weather forecasting. And I want to hear all of your takes on whether that was an accurate description. But in the 2-ish years since, it feels like this has become a really central part of the conversation around how we could and should be using AI in the energy sector. And last year when DOE put out their report kind of prioritizing where we should be implementing AI in the near term for energy, weather prediction was in 2 of their 4 categories. So it's become a very big topic. I'm really excited to dig into it today. I will briefly introduce our panelists, and then I'm going to hand it over to them to give us their fun, icebreaker, 1-sentence intro to what they do in a day. If you want to take notes from the Barbie movie, my job is weather balloons. That's encouraged, and if you want to take it more seriously, that's fine as well. Over here on the end, we have Julian Green. He's the CEO of Brightband. Thanks for having us all here today, Julian. Next to Julian, we have Mike Pritchard is the Director of Climate Simulation Research at NVIDIA. Thanks so much for being here, Mike. Ryan Abernathey is the CEO of Earthmover, a cloud platform for weather and climate data. And last but not least, we have Austin Tindle and also Denise Pearl. So Austin, in my notes, is the CEO of Sorcerer. And Denise leads global strategic partnerships for sustainability and new energy at Google. Okay, we'll start down here with Julian. 1-sentence description of your work day-to-day at Brightband, and then we'll jump into my questions.
Okay, 1 sentence. How many commas are we allowed? So yes, I'm Julian Green. Okay, fail. I guess I need to do some more theatrical training. I love this cozy environment we're all in. So I'm Julian Green, I'm the CEO of Brightband. We have been around for a year and we make AI weather forecasting tools.
I'm Mike. Yeah, I'm Mike. So I lead a research team at NVIDIA Research. So my day-to-day is having my mind blown routinely by where these people find amazing opportunities for AI across the Earth system modeling stack.
More fun than Julian's single sentence. Thank you, Mike. You're getting into it.
Okay, my day-to-day is a data plumber. We come into and try and find where people's data pipelines are clogged and just clean it out and make all the data flow smoothly.
The clear winner so far.
When's the phone up?
Denise?
Good morning, everyone. My name is Denise Pearl. I am the Global Market Lead for Sustainability in Google Cloud. I am not a plumber. I am not an Earth observation expert. I'm the person that basically takes the technology and builds stories around it to help our mutual customers understand how to actually use it. So applying it to their business. So you gave the example of energy. We actually see the applicability for weather across many industries. So oftentimes customers though ask, and I've heard it numerous times this week, give me a relevant example of how I can use this in production today. And that's the job that I have.
Amazing.
Hey everyone, yeah, so maybe kind of preempted my fun icebreaker. My day-to-day is weather balloons, so that's pretty much all that I do. Launching them, recovering them, looking at the data that comes off of them, everything up to and including climbing up into the trees that they get stuck in and fishing them out, so that's me.
Perfect, this got better as we went along. I'm sorry, Julian. Denise, I want to start with you and Mike here because I think of NVIDIA and Google and kind of what you just described as sort of the foundation or the backbone underlying the work that everybody else up here is doing and that others are doing. Can you set the scene for us? I mean, where are we right now with AI weather forecasting? It seems like things are evolving really quickly from this sort of bird's eye view that Google has. Where are we today? Drop a pin for us, if you will.
I do think there's been this incredible transformation, and there's people in the audience, by the way, who do this great work at Google. So I'm just going to say that right now, that if you have really in-depth questions about that, ask Mike or ask some of the folks in the audience. But I think there is this shift from traditional ways of doing weather forecasting to AI weather forecasting. And even within Google, just observing our research teams, what I've seen is, we released GraphCast and then GenCast, and they've quickly moved over into commercial offerings in Google Cloud called WeatherNext. Because customers are saying, this amazing technology that you all are building, how do we actually incorporate it into our business? And so what's been interesting is you build these amazing new models like GraphCast or GenCast, but once you start using them, you start to figure out that you do need the plumbing. And you do need the additional data, and you need all of these amazing companies that can help you process that and integrate it into your decision support. And so I think we're very fortunate at Google that we have amazing research teams that are building these things, but then in Google Cloud, we're picking them up, like I said, to make it usable, to make it applicable in these decision support systems, but through ecosystems like the one sitting on the stage today. Mike, what do you think about that?
Yeah, I love that. Yeah, so we're also just very interested in the ecosystem as a whole. I think NVIDIA's work in this place, well, first of all, it's an excellent use of GPUs, and it's unequivocally a good use of GPUs.
Sometimes TPUs.
And sometimes GPUs, yes, absolutely. And AI in general, I mean, it's amazing. I'm an atmospheric scientist by training, so I've spent a dozen years as a climate science professor, and a whole new way to simulate the atmosphere was born, and no one expected it, and it has completely new properties, and they're fascinating. And I think we're still in our infancy of understanding the implications. AI weather systems should be able to use much more observations, much more flexibly. We don't know the limits of the predictability of the system, and we all think that our sense of that's going to be changing. At NVIDIA, we serve our models like ForecastNet 3 and Reporter for super resolution or state estimation or prediction through an open source AI for science product called Physics Nemo, which is licensed under MIT, so it's completely free for reuse, including commercial reuse, training pipelines, and checkpoints. And so the goal is definitely ecosystem acceleration. Let's find out what's possible at this new frontier. Together, we can do things more quickly and better together.
Perfect. Thank you, guys. And before we move on, I do want to do just a little bit of grounding so we're all kind of on the same page. And Mike, can you walk us through how do AI weather forecasting models compare to the traditional way of forecasting weather? And when you're describing all of these breakthroughs, what would you categorize as the biggest ones or the key ones that we should be thinking about in the last 2 to 3 years?
Do you want me to stay? You want to stay?
Oh, you haven't spoken. You want to take first now?
Yeah, so we should celebrate, right? As Mike said, that this is sort of an amazing application of AI. And to be honest, coming from the AI side, I was surprised that weather and climate hadn't used AI sort of earlier, in that it's very data rich. And as usual with AI, it was sort of the release of a data set which people could play with easily. The Era 5, properly formatted, on Google Cloud and other places that people could start to work with as their training database, as their initial conditions, as their verification data set. And in 2 years, we've seen AI go from okay to amazing. And weather physics prediction has been around for 70 years, and so it's sort of astonishing. And, for those who've been in weather longer, I know that it's really, to the extent that 3 years ago people were still saying, that's not physics, it's not really going to work, right? And now it's, oh my goodness, this stuff is amazing. And in terms of being better, it is better at sort of 2-week global weather, and it is maybe 10-20% more accurate, and that means that translates into a half a degree of temperature or a few degrees of temperature over maybe a 7-day timeline. It translates into a few tenths of wind speed accuracy over that same time. And so it is more accurate on sort of the global averages, errors ways that we measure it. I think we have yet to see all the other ways that it is amazing and useful. And so with AI, the fact you've just made something that used to take $1 billion supercomputer, hours to do, now happens in seconds and minutes, that you can run anytime with magnitudes, orders of magnitude larger amounts of data, and you can develop ensembles and the full probability distribution function, because weather is inherently one where you want to see the different scenarios. And so your call in 2023 that we were in the early stages of AI weather, it's already made 70 years of progress in 2 years, and we've only just begun.
That's perfect. And so it sounds like we aren't necessarily yet at a place where AI weather prediction is fully replacing traditional numerical prediction. I'd love to have Austin and Ryan weigh in. Where are we? What does it look like to complement traditional weather forecasting with AI? Where are you seeing the best use cases, the early use cases, the fastest adoption?
Yeah, so I don't know if I'm the best person in this panel to take a stab at this, but I'll do it. I think right now, from my perspective, the biggest places that you're seeing widespread adoption is in those places where it's been typically too expensive to run numerical weather prediction models, and so there are a lot of smaller scale use cases. There's a lot of research use cases. There are a lot of people that can use or develop on or play with these models that wouldn't have been able to otherwise. There's a lot of experiments that you could run that would have been too expensive. So that's a really interesting place where they're getting a lot more use that I've seen. And Ryan.
Yeah, I'll just pile on. I feel like, given the nature of what we do, sticking with the plumbing analogy, we can see where people are building houses, right? Building new houses. And what's really exciting to me, my background is, like Mike, as an Earth system modeler. When I left academia and sort of transitioned into the private sector, just a couple years ago, I was shocked how nobody was running models. And to me, models were like this really key tool for understanding it. It was all just about, we're just going to analyze data and kind of stop there. Famously, the only hedge fund that was really doing numerical weather prediction a few years ago was Citadel, right? And there's articles about it, you can go read about it. They hired big teams and they spent millions and millions of dollars on supercomputing. That was the technology that was needed to do that. And now, with AI weather models, very, very small teams of smart people, especially with some capital to deploy, can run those models, can get very unique and special, fine-tuned value out of them. And this is, from our perspective, driving a real gold rush right now around looking for ways to leverage those specifically in energy markets and commodities. And so that's super exciting from a scientific point of view, and it's doing things in the market as well.
Please, Mike, Julian, want to weigh in?
I would say, I agree with what you're saying. I think, like you said, we can see where the plumbing's being built. And so we are afforded the opportunity to talk to customers across all industries. So that could be public sector, it could be financial services, but it's healthcare, it's CPG, it's retail, it's utilities, all of them. And when you sit down and ask them about how they're thinking about sustaining their business in the future, weather is often a consideration. And to your point, I think that in the past they were restricted or limited by how they could insert weather visibility into their decision-making process. But now, like you said, because there's been efficiencies gained on the infrastructure, what took days and millions of dollars, now you can do in minutes. And this idea of having maybe the opportunity of not just one prediction, but 70 potential predictions about what could happen, just gives people a lot of opportunity to imagine how they can do new things. One example that I live in California, so we deal with both wildfires and flooding, in some cases in some areas. All of these things are very interesting. And like if you're a vineyard, you want to know about both. You want to know about regular weather conditions. You want to know about extreme weather conditions. You want to know about the smoke from a wildfire, the trajectory of that. You want to understand about these flooding incidents. Being able to bring all of that together, I think, through what you guys are all doing and then inserting it into an actual business workflow, every industry can benefit from this. And now they actually have the opportunity to do that. So it's pretty exciting.
So do you think a vineyard is going to run their own proprietary weather model? Is that something that's happening?
I don't know that they may work with amazing partners who are also building domain-specific models, or there could be models that have been created that they just benefit from. That's again the ecosystem. As you guys are all building this out, I don't think companies have to go necessarily develop the in-house expertise. They can point to amazing companies that understand this, and what they do is they just ask you the business problem. This is the business problem that I have. I can't understand my susceptibility to XYZ, and so help me see that. And they may realize that they don't have the in-house expertise, but now that you guys are all building these solutions, they have access to it. So absolutely.
So Denise has raised what I think is the most exciting thing that I don't think most people get yet, right? Which is it used to be only governments basically could run models, and they run them every 6 hours on billion-dollar supercomputers. Now anyone can run a model. It's cheap, it's quick, and we're starting to get the tools and the data and the ability to make that really, really simple for people. And the importance of weather is crazy. A third of the economy is very weather driven. US GDP fluctuates by 3% every year if you isolate weather as a signal. So it's this massive effect on most people's lives and businesses. But it's sort of sucked so far, right? I mean, as amazing as the sort of scientific achievement of forecasting is so far, it only goes out so far in the future. It's not terribly granular. You sort of get these weather metrics, temperature, wind speed, and so on, which are interesting. But what you really want to know is, how should I make my decisions that rely on weather? Is the energy price going to go up? Should I take an umbrella? Which streets can my trucks go down without hitting ice, right? All these questions that you actually care about. The future is hopefully Brightband and others providing tools to people to be able to answer their weather questions and make better decisions.
That's perfect. Quick reminder for the audience, we're going to leave time for questions at the end, so be thinking of them, and we'll come back to you for maybe 20 or so minutes of questions at the end. Mike, before we move on, because I do want to chat a little bit about performance assessment and what makes you so sure that if this is a great use of GPUs and occasionally TPUs. Can you
Thank you.
say a little bit about, in the research world, how are you thinking about when we will truly shift over entirely to AI weather prediction? How far out are we looking right now with AI weather forecasting, and how certain are we as we look further and further out? What's the future of that?
Well, I think you should look to the most credible, most experienced practitioners of operational weather prediction for answers to questions like those. So I watch them carefully. The NYCW is a great example. They're intentionally maintaining a physics model and are building an ML model that's fascinating. And the cross-pollination there is actually fascinating. One of the things I've been most impressed that they've done is they take their high-resolution physics model, which gets wonderful detail of convective events that are relevant to these impacts questions on infrastructure. But these high-resolution models never kind of paid off. The bet never paid off for improving broader skill. Got you detail, but not skill. And they're marrying them with the AI model. And they're nudging the high-res physics model on the macro scales to the AI models, and sort of this cyborg physics AI model has emerged, and to your point about the pace of increase in skill, 15% skill bumps in years compared to decades from doing these sorts of things. But yeah, I think it's not a coincidence, and probably logical right now that most meteorological agencies, serious ones, are maintaining both physics models and AI models. But then again, the scores are unequivocal. It's not that hard to score an AI weather model and to convince yourself that there is real skill beyond the capacity of today's physics models, today's best physics models, on the medium range. And so the proof point's there.
Same journey where people enjoyed the output of Google Earth, especially during COVID. You could sort of engage with a platform and go visit Rome, and all of that though was powered by these enormous geospatial backends. And it took a certain amount of domain expertise to build those pipelines, to collect that data, to process it in a way, and then serve it through a platform like Google Earth so that people could use it. I think that we're on a similar journey with weather, where we just have to find these domain experts, and we have to sort of document and curate that journey, capture the benefits and the metrics so people feel confident in incorporating it into their business. And then I feel an obligation for a company like Google and Google Cloud in particular to identify companies like yours and figure out how do we bring, if it's talent that you need, if it's capital that you need, if it's just helping to tell your story globally and how you're actually doing this work. I think that larger companies that maybe have a platform to share that message, that's how they can lean in to increase adoption.
I don't think we've talked about data enough on this panel. Mike mentioned that scaling laws and the notion that there's a lot more that we can still get out of data-driven weather modeling. That only can happen with more data. I mean, that's what we learned from LLMs, and it's no different. Right now, data collection, at least in the US, is actually at risk. We're at risk of having fewer weather observations, whether that's through canceling key satellite missions or reducing the National Weather Service capability to do soundings. That's why I'm a huge fan of what Sorcerer is doing, and then also Brightband to try and make that primary data more accessible. So this is what I want to know is, even can the AI models tell us where we need more observations in order to increase skill for some particular metric, and how do we get them? Ultimately, I think this is what's going to drive, really, like the AI technology is moving so fast, but like it's all ultimately limited by the data that we have about the Earth, and we got to keep that growing very strongly. And I worry sometimes about where things are trending.
Yeah, I'll just add to that. I'd be remiss not to talk about the data, but only about 15% of the atmosphere is well observed when it comes to in situ data types like weather balloons and aircraft observations and ground stations and that sort of thing. And that boggled my mind, at the outset of working on Sorcerer, was just how little high quality, high impact data there really is that goes into actually feed these models. I mean, it's amazing that we're able to get the performance that we can out of today's models with how small the data sets are in comparison to some other model types.
As a researcher, I'm looking at where AI has yet to achieve its ultimate impact in this space, and I think the complete liberation from physics models, the unification of AI data assimilation with AI prediction is fascinating. Direct observational prediction, the data needs are going to skyrocket as we get into this, but things become unlocked like forecasts on demand and the ability to assimilate far more data streams than have been assimilatable into the gridded products that most AI weather files have been trained on so far. So it's a very exciting future. And then as always at NVIDIA, since our mission is fully open source and to boost ecosystems, we're looking for ways that we can scalably transmit our own learnings into the ecosystem in ways that authentically accelerate others. And so one hope is that recipes transferred into physics NEMO or prove easy enough for people to build on, but always interested where people have bottlenecks in their workflow, where the kind of the talent at NVIDIA can be especially impactful. I mentioned deep learning optimization and performant ML scaling. Always on the hunt, looking for those sorts of things too. That's what I monitor.
Yeah, I think just trying to tie together the things that have been mentioned, I think collaboration is key in the weather space. And on the data side, we've been fortunate that in terms of international scientific collaboration, weather is a shining example of countries realizing that they need each other's data to be able to predict their weather, because one country's weather yesterday is your country's weather today, and you need to observe the whole globe. And so collaboration on data, so we monitor our data feeds and see if stuff is drying up, because that would be bad. We at Brightband have gone to the observations, sort of the raw data, of which there is much more than is currently used. And we think that's an interesting approach. Others are also looking at that. So we assimilate that data, and once you have AI, both in the dealing with the data side and then in the forecasting side, you have this end-to-end AI pipeline, you can start to value different observations and say, if I had more of stratospheric balloon readings, how would that contribute to my skill for particular applications? Because you have just a much more flexible modeling approach. And I think the battle against other things that smart AI people could be doing. I think we need to win that for what we think are important problems in weather and climate. I sort of talk about David Donahoe's approach called frictionless reproducibility. And he says, he's a professor of economics at Stanford, and he says the reason LLM innovation is so crazy right now is because there's the data, the model, and the metrics that are available open source for people to try different ways to solve the problem and then to compare how well they're doing. And so in weather, we need open source data, open source models, open source metrics, and we're getting that from some of the folks on this panel, so that everyone can try the same weather problems, compare answers, see what works. And I think step one is making weather forecasting much better, and then both the world and all of us benefit.
My next question was going to be about biggest challenges to scale, but it sounds like the answer is resoundingly data.
And people.
And people. And billions of dollars in funding.
I want to double click on the person thing. I think training by linguists that have enough domain science and enough cutting edge AI inside one brain. It's not enough to have these siloed in two different brains. These bilinguists are hard to train, not many of them exist. It should be a priority for higher education. Some centers, including here in New York, are trying to train them, like Columbia and elsewhere, and NYU. But it's still, I worry about the personnel supply sometimes.
Let's stop there and see if we have any audience questions. If we don't, I've got okay, we do. Great, shall I pass the mic around?
Sure.
Do we have a Brightband team?
Sean, would you?
Hi, Andrew Lala, CEO of Ignitia. We're one of these cyborg solutions that's applying physics-informed AI. We're part of NVIDIA Inception, thank you, part of Google Startups for Sustainable Development. One of the things that strikes me is AI models have not caught up to extreme events because there's no observation data in the past for us to be training on. And I'm wondering, these are the types of events that cause the convective storms, Tropical Storm Sandy, the flash floods in Texas. How are you thinking about the outcomes of this AI model? Because it's good if you get a 1-2% performance increase on wind speed, but by and large, we haven't seen it really capture yet these extreme events that are wreaking havoc on the economy. So I would love to kind of hear from the panel how much of it is a problem where we need more than 15% coverage of weather balloons and sensors. We need more models to be addressing not an incremental change in the way that we forecast, where numerical models do an excellent job, but we need to be asking the right questions of those models versus the vineyard owners. I'm shocked by how few businesses are actually leveraging tools we have today for better business outcomes. How are you thinking about those barriers for the future?
So I'm going to challenge the premise. I think a lot of people instantly jump to, because AI predicts the weather by training on the past and saying there wasn't exactly this thing in the past. How could you possibly predict it in the future? The data shows that, let's take hurricane prediction as an example. Hurricane track prediction, and you sort of want to know where it is and you want to know how bad it is in intensity. But the hurricane track prediction is now better with AI, and it's better by a couple of days on the 4 or 5 day prediction cycle. We need to make sure that we're measuring that across all the hurricanes, and we're doing a good job of. But it has done a great job on a bunch of recent hurricanes, and also a more accurate landfall prediction. So the big problem with hurricanes is, it's going to hit somewhere in Florida, and there's a lot of people who live in Florida, and we can't evacuate all of them. So could you tell me, which million people need to move? China just moved 500,000 people because of a tropical cyclone hitting them, and it takes quite a long time to evacuate hundreds of thousands of people, right? So that accuracy in landfall, which is much better with AI, is also exciting. And you can see this, Google has a nice visualization with Weather Lab, where you can see a bunch of models there and sort of dots flying around of where it thinks the hurricane could go. And then hurricane intensity, it has been less good with AI, but there's now some new research papers out that actually demonstrate that if you give AI the objective of doing a good job, not only sort of on average, but in an opinionated, sharp way on something like hurricane intensity, we may be solving that problem as well. So at least for hurricanes, I reject your
Politely.
No new rainfall.
Precipitation's hot. Actually, ECMWF just put out a model today. I don't know if, for the experts in the audience if you saw that, and they have done a nice job. AI was predicting quite frequent low levels of precipitation, and that was a way to meet sort of its average goals, right? And in some cases was predicting negative precipitation. If you can tell me what that is, that would be impressive. But even the physics models show, rain going upwards. Even the physics models actually sometimes predict rain when there aren't any clouds, which seems unlikely. But what ECMWF has done in its last model is they've sort of put not a post-processing step, but the last layer step where they put on a sort of a activation function where if they're predicting sort of immaterial rain, they just assume that that's not rain, and so now it does a much better job.
Yeah, I'll just add to that a little bit to the question. Totally agree with everything Julian's saying. I would say the additional point that we're looking at as a weather balloon company, knowing where more data or targeted data would be useful is fairly unsophisticated right now, even for high impact and high cost events like hurricanes. Right now, essentially, we'll double radio saw launches in the Midwest and fly hurricane hunters to drop sondes into hurricanes, and that's kind of the extent of like more observations to help better predict an extreme event that we have right now. And it's that's really the main example of how we do that. There aren't really other types of extreme events that we do that type of work for. So knowing how we could have our observation infrastructure react to extreme events and where more observations would actually be helpful is something that I think needs a lot more work and something that we're actively working on.
I think I start to gain trust and faith in the ability of AI models to predict out-of-sample very small events with some extrapolation halo when I think they've learned physics. And so that's heavily dependent on the space-time resolution of the training data. When you're dealing with the kind of Air 5 data, 25 kilometers in space, 6 hours in time, there's some phenomena I think can be learned quite well, like large-scale planetary waves, Rossby waves, and therefore heat wave extremes. And I think there's really good evidence that heat wave extremes out of sample can be predicted well. Like very extreme heat waves can predict away heat wave counterfactuals. For hurricanes, I think it's just kind of entangled with the question of higher resolution AI-led modeling as we look at richer data sets beyond the Air 5, whereas I'm beginning to think the physical processes that I know cause hurricane intensification are visible to the optimizer. So that's really an interesting resolution frontier.
Questions?
Hey, Julian Spisecki, recovering academic and freelance software engineer right now. I wanted to follow up on sort of the importance of data and would want to bring it back to sort of the funding model. I think you've made a very compelling case of the sort of feed-forward potential of weather AI forecasts, but I'm curious what y'all are thinking about sort of funding and sort of the worries about consistent funding for government-based data products. If you see these things sort of being completely taken over by the private industry, or if there could be a funding model that feeds back, and whether that is sort of very nation-focused or more distributed.
Well, I don't know if I can answer your question, Julius, but I'll just state something that seems pretty obvious to me, which is that things are really being disrupted right now. The traditional model wherein public sector government agencies provide the leading forecasts and do this as a public benefit seems to be at risk. A few years ago, we might have said, well, they're always going to maintain. They always have the data, though. They're doing the balloons, so fundamentally everything will go back to them. I'm not so sure that's true anymore. We see a lot of private sector companies that are investing heavily in satellite technology, observations. Obviously, not at the scale that can replicate the public sector, but it is at risk. And there is a risk of a world in which I think good weather forecasts are accessible only to people who can really pay for them, and that's not the world I want to live in. I do not know how to solve it other than leaning into values that a lot of us share around open data, open source, collaboration. A lot of things have been said over and over, but there's a very strong market incentive that may be working against some of those trends. Maybe others have insights.
Yeah, it's a great question because it is very disruptive. When one group of people was sort of the only people who could do something, and now many others can. I was just at the World Meteorological Organization AI Summit in Abu Dhabi, and a lot of the national Met offices are trying to work out, what the sort of existential, issues. And the agreement there, and from private companies and from the Met offices is, the last thing you want is to lose that authoritative government voice about the weather. Right? If you're trying to keep people and things safe, that fundamental role has to be governmental. You don't want no private company would want the liability of suggesting evacuations and telling people they're safe. That seems like a obvious government role. But at the same time, some of those Met offices have made money, selling commercial weather products. And so how do you square the circle? Realistically, most of the observations are still governmental. So the vast majority of satellite, but that is changing. And so it's now cheap to put up a LEO or a GEO satellite. It's now cheap to put up, drone type, mobile observations, and so you will see increasing amounts of commercial observation. I'm as a startup person, I'm an optimist. I see the capabilities of weather and climate forecasting becoming much greater, and there being much more work for many more people and much more value to those using it. So I don't see that everything's going to fall apart. I think that we will continue to have a strong government role, and we will see increasing capabilities. And at the very basic level, we talk about people. You're sort of trying to put AI, people and technology, and weather, people and weather and data together. And so you need new people coming into this to help the innovation.
Yeah, I'll just say briefly at NVIDIA, we care a lot about sovereign AI and independence and the ability to make one's own AI, and that's very much part of our weather and climate tactics as well, is to make sure we have open source training recipes, open source checkpoints, and everything anyone needs to build a frontier AI weather model themselves if they want to. And on the data point, I do understand some data streams are relevant to national security, and whether it's part of national security, it's very important to be mindful of the need for sovereignty in this space. Thank you.
Yeah, and I would just add briefly to that the government absolutely needs to play a role, needs to be their authoritative voice that's freely available to as many people as possible.
Weather Quest, the European Center for Medium Range Weather Forecasting, is currently hosting the first the largest scale international coordinated AI for sub-seasonal to seasonal forecasting worldwide competition. And so this is being benchmarked, and there's dozens of teams internationally who are going to discover in a few months what the current state of capability is for AI prediction models on those timescales. As a physicist, I think it's clear ocean dynamics and ecosystem dynamics become important sources of memory on those timescales, and so there are a few teams that are building multi-component AI atmospheres coupled to AI oceans coupled to AI land surface models. There's a whole host of new technical problems that come there, really exciting ones, about coupled optimization and coupled fine-tuning. But rest assured, it's a very active research frontier, and we'll know something concrete in a matter of months, thanks to this large international competition.
Yeah, two week weather, or maybe 2 weeks plus a little bit is sort of where AI has done a great job so far. To be honest, with apologies to folks that do sub-seasonal forecasting, it's really hard, and there's been very little signal so far. So for farmers who want to know, what my next month or two's decisions should be on fertilizing and seeding and harvesting and so on, their best bet is to go to the Farmer's Almanac, or to ask the neighboring farm. So that is something where I am super optimistic about AI's ability to improve sub-seasonal forecasting, and very excited to see what happens with this competition in general. So yeah, watch this space. It's not just 2-week weather, it will be many other things.
Okay, and with that, I will release you all from your seats. Thank you so much. Join me in thanking our panelists. You guys are wonderful. I really appreciate your insights, and find them out in the lobby for your other urgent burning questions. Enjoy the rest of Sunny Week.